So we're going to talk about rates of change and tangent lines. So remember, rate of change is really just slope, so we're really just going to talk about slope through this whole section. Now, we're going to add some concepts to our idea of slope and the concept of limit, so it's going to maybe look a little funky, but let's remember that when it all boils down to it, we're really talking about slope. All right, so find the average rate of change of f of x equals x to the third minus x over the interval 1 to 3. All right, so my function looks like this. Okay, so you can get those points that I did. This is 3, 24, and this is 1, 0. You can get those by substituting the x value right into the function. So f of 1 equals 1 to the third minus 1, that's 0. And f of 3 equals 3 to the third minus 3, that's 24. You can get those that way. You can use if you graph that on your calculator, okay, and push trace, and then just hit 1, enter, it will give you the values, and 3, enter. That's a quick way to get values. And so to find the average rate of change, remember, we're just finding slope. So m equals 24 minus 0 all over 3 minus 1. That gives me 8. When all is said and done, my slope is 8. All right, so that's the average rate of change. Now, the formula for average rate of change, remember, is just slope formula. All right, y2 minus y1 over x2 minus x1. But your book and in general, another version of slope formula is when you actually use function notation. F of b minus f of a all over b minus a. So in other words, think about this being your a value. How did we get our b value? Well, we substituted the 1 in, and we got out f of 1. So a comma f of a. We did 1 comma f of 1. All right, so that's another way you can write a point. Actually, this is considered a way to write the point x comma f of x. That would be the value you get out. That's another notation. All right, so slope. Slope you might see in either of these versions. This is the one that we're going to use today. Really, that's just x2 minus x1 on the bottom there, x2, x1, and y2, y1. Now, we're going to talk about an example. So, experimental biologists often want to know the rates at which populations grow under controlled laboratory conditions. The graph shows how the number of fruit flies grew in a controlled 50-day experiment. The graph was made by counting flies at regular intervals, plotting the points, and drawing a smooth curve through the points. All right, so it's a regression curve, if you will. And some of the points they got are these 2 points, P and Q. Okay, and here they are over here on our graph. And it wants us to compute the average rate of change from 23rd day to the 45th day, basically, from 23 to 45. So how do we do that? Okay, well, we use the slope formula, y2 minus y1 all over x2 minus x1. And if you actually calculate that out, now I want to go back and do units in a minute. It's about 9, okay, it's 8.6, right? It's flies, so we better not have a decimal number of flies. But remember, this is the number of flies, right? Y is the number of flies, so flies. And the bottom unit is days. So remember, divide means per, so literally that is flies per day. Okay, it's flies per day. It's a nice way to figure out your units, to use the units and see if you put the units into what you're calculating and it ends up giving you out the units practically.